So hello, my presentation today is basically to explain the basics of ROS that we learned yesterday through the practical example that I've implemented on the motors. So the workspace that I'm using is Robot 7M. As we learned yesterday, there are build, devel and SRC folders. These are two meta packages, Robotus framework and Robotus manipulator. Framework is basically related to the maths portion and communication with the motors, and Robotus manipulator is related to the higher level planning and control. So these are the four packages inside the Robotus manipulator module, and as you can see that all four of them have quite different tasks, and that is basically what packages are supposed to do, that each package is supposed to do a different function and together they interact and communicate so that they can do a much larger task. And usually in such large programs there is one particular package which is like the entry point to the package. For example, if you want to run this program, this manipulator manager is the first thing that you need to execute. So to execute this package, any package, any executable in the package, there are two commands, either ROS run or ROS launch. Now the two main differences, uh, uh, there are some advantages of ROS launch over ROS run. The first advantage is that if there are some parameters that you want to uh, input into the parameter server at runtime while executing, then you can do that through launch files. For example, this. Okay, wait. This is the This is manipulator underscore manager dot launch. So as you can see, there are quite a lot of parameters that are being inputted at while executing it. Let us look at this dxl underscore init dot yml. There are so many parameters to input, and it's not possible to do this. As in yesterday, the method that we learned for get param and set param, that's okay for one or two parameters, but so many parameters for 7 motors, it doesn't make sense to input it one by one. So you can directly just give the path to the file, the parameter config file, and that will allow you to input the parameters while executing. The second advantage is that suppose using this manipulator manager you want to start 3 different nodes which are doing 3 different tasks. Instead of doing ROS run 3 times, you can instead take the example of Robotus manipulator RViz. There are 3 nodes that it is executing just by ROS launching this one file. So that saves time and it's quite efficient, since the three, like you are working only in one terminal. And even with this node, as you can see, you are using a parameter use GUI. So that is the second advantage. And the third difference is that in ROS launch, it automatically starts the ROS master instead of ROS run, where you need to type the command ROS core before running ROS run. So that is the difference.
Are you using the Python version?
No, C++.
Can you go to the last page? Xacl.py, something written.
This is actually, I'll come to this later. These are Zacro files, and they don't really need a Python or C++. It doesn't really matter. As in, there's no specific Python code that you need to write for a Zacro file. I'll come to that at the end. It's included. So just so the manipulator manager, once it executes, it starts the communication with the motors. So by communication, obviously we mean that it publishes messages on certain topics. So it is So uh, this is a visualization tool called RQT underscore graph, which allows you to see the different topics between the nodes. So before this image, there was also one node that was executed, robotics manipulator GUI. So so these two nodes are publishing and subscribing to these topics in the middle, base slash set mode message, base slash kinematics pose, etc. Now one thing is that you can see that there's a robotics written at the top. This is called the namespace. What Hashir mentioned yesterday was that there can be an absolute name of something and a relative name. So basically, it allows you to, it's sort of like a nickname for someone. He has his actual name, and there's a nickname that defines that, yes, this is the exact topic that I want to talk to. If there is, suppose, another robot, that you'll obviously be sending the same messages, the same topics will also go to that robot, but you'll maybe name that robotus 2. So that's how you can differentiate between two different robots but using the same topics. So now then let's go on to the other important part of ROS, nodes. I'll just show you a very simple ROS node. This is input.cpp is just a publisher node to send the joint angle and the kinematics pose. Just observe all these include statements. I'll come to that in a little while. So this ROS init, it's basically you're creating an instantiation of the ROS node. This is ROS node handle n. It's like in object-oriented programming, we learned objects. So this is basically an object of this node. And these are two publishers that I've defined, k underscore I, j a I, and they're publishing on two topics, kinematics input and joint angle input. The message type is manipulator base module messages kinematics pose and joint pose. So that is defined here in this. As you can see, these are user defined messages which include string and float, and similarly there's a kinematics pose is string and geometry messages pose. But there is one small difference between this. This is a vector, while because we have 7 joints, so this includes the joint angle value for all 7 motors, and this is just the kinematics pose for the entire arm. So yeah, then on this topic, this message type, there's one variable message msg and kin, and it's simple. I'm just giving some values to these messages and then I'm publishing them. So that's usually nodes the nodes aren't this simple, but publishing values is actually this simple. So when I'm publishing on these two topics, so let me show you now. The RQT graph is slightly different. This, you can see here, this input node is publishing joint angle input. This photo was taken before I added the kinematics pose input. So this is joint angle input and it's publishing it to ROS out. One other difference you can see is that there are many more topics here, and that is because if you can you see the cursor here, leaf topics. We've said hide leaf topics. Leaf topics are those topics where a node is publishing but there is no other node subscribing to it. So it's basically just a dead end. But in this image, even leaf topics are included, which weren't included before. See, as you can see, this one, there's no node subscribing to it, but it's there in the RQT graph now, but it wasn't there before. Yeah, I mentioned about these include statements. So ROS has to understand where these messages are to be taken and what other dependencies have to be given. That is mentioned in it's mentioned in the CMake list and the package.xml for input. So input.cpp was defined in robotics manipulator bring up package. So this find package catkin is always required because CMake list what it basically does, it informs the system how to compile and where to install the executables. So this finds the package and catkin and the required dependent components. So as you can see there are, so this includes both predefined dependencies and user defined. This robotics control messages and manipulator base module messages, these are things that are defined by the user, whereas these two and these two were predefined when you installed ROS. And eigen is also required because of, well, it's commented out because, but this rpy2 quaternion, this is a eigen function. So then right towards the end, this this add executable input using this source file src/input.cpp. These are the basic syntax of CMake lists. That's why I'm just going over it quickly. And package.xml. Like we saw yesterday, the run depend, build depend. Now is the similarity that I would like to show. The standard messages are already part of the ROS CPP, which we are mentioning the dependencies here, run and build. Geometry messages, eigen, and manipulator underscore base underscore module messages. So that is the reason why we have to mention this in package.xml, so that the include statements the compiler is able to understand. Yeah, now you can see this MSG which I showed were two messages, joint pose and kinematics pose. But this SRV is also a very important thing. This is for services. Messages and services are the two ways by which communication happens. Messages, what we saw is that a publisher just keeps on broadcasting its messages and anyone who needs it can uh, subscribe to it. But services have two different things that it does. It gives a bidirectional character and it gives a one-to-one character. Bidirectional meaning that suppose I'm a node and I need some data from another node which is not publishing, as in which hasn't been executed. So I can send a request to that node to start publishing, but only to me, and it will send its data as a response. So as you can see, this SRV, it consists of the request and the response. So this get joint pose, it is asking a node that for this joint, please send the joint value. That is the bidirectional character, and this information will only come to the node who is giving the sending the request. So there's a one-to-one character as well. That is the major difference between messages and services. So, so I think this is we've basically seen the main core concepts in ROS, which is nodes, packages, messages, services, topics. But other than this, ROS gives a lot of other functionality as well, which is like the RQT underscore graph. That is a visualization tool. But the main one that is there in ROS is called RViz, which basically, as in ROS actually names are very obvious, like RViz, ROS visualization. So we saw yesterday RViz was used to see the point cloud from the Kinect, but RViz also does many other things. See, this is the kind of a disadvantage of ROS run. There was no master, so I have to define a ROS core. Oh, I need anything. नहीं नहीं वो आई थिंक नया विंडो खुला है ना, तो इसलिए होना नहीं चाहिए. So yeah, this is RViz, and let us see. So RViz has a lot of other functionality also, which is actually very important. So you can define axes, depth clouds, laser scans, a map, marker arrays are important. The point cloud 2 that we saw yesterday, point cloud 2 path. And what I would importantly want to show is, since we're all mainly working in robotics, robot model and TF. So when we see a robot, we can understand, you just by seeing the CAD model, we can understand what are the characteristics of the robot. But we need to convert a robot model into the form that ROS can understand. So for that, ROS also provides us with another tool which is called a URDF, Universal Robot Description Format. So this is basically for ROS to understand what the robot is, as in how to define it. And this is done in .zacro files, .zacro and .urdf. .zacro is basically a tool by which it's easier to define these things. So as you can see, basically it just defines a robot using links and joints. There are different kinds of elements in links and joints. For a link, you can see these three are usually used: collision, visual and inertial. So visual, as you can see in collision and visual, I've imported the CAD files for it to be visualized. We're just defining the origin, and that's actually a little complicated. The origin is with respect to a varying coordinate frame, but the main thing is that you're able to visualize the link, and you're able to give a collision link, because using this URDF you can further do collision checking also. And this is the inertial thing, where you give the center of mass and inertia, etc., and the mass. So, and this is the joint. Joint, you can have different types: the revolute, prismatic, etc. You define the parent and child link and the origin and axis of, like for a revolute, this is the axis of rotation. And you can also define some limits on the velocity and the rotation. So this is how you define.
Okay, I want to see that where did you import the file from the CAD application? You imported the file from the CAD model, right?
Yeah. So this was in a different workspace. I was just doing a practice. So in URDF you can see this robot.zacro, which is the file that I was showing, and here meshes, and this is where all the CADs are.
Okay.
So that's one thing, the CAD has to be physically present. It can't be as in not from the internet or something. As in, that's one mistake. Like if you download it directly from the internet, if you download the package from the internet, but if you don't download the CAD files, then it'll give an error. So
What are these RP,
So-
row, which your values are?
yeah, roll pitch, yeah.
So is it for a mobile robot?
Yeah, it can be used for a mobile robot also, I think. The only one that I think it can't be used are parallel manipulators, as in which are I think cyclic and there are multiple links which are moving at the same time. But I think it also works for mobile robots also.
Roll pitch yaw are just a method to represent the different things. It doesn't matter that what it is for mobile robot or for any manipulator.
Actually,
These are the the basically the joint angles.
so if we have just like this
Roll angle, pitch angle, yaw angle.
if
That's
we have one link manipulator,
so the other angles will be zero. Or the
I think
This
so.
is the representation for the single link or the
For this link,
for single link.
yeah, for single
I
link,
think it's the relative angles between the
origin
starting
and the
frame and the end of the link.
yes,
Something like
something
that.
yeah. And as you can see, like there are lots of links, 17 links, like for each of the 16 motors, and there's a link and joint defined. So let me. This is the package name. Oh. Test dot underscore description. Then the name of the launch file, display.launch. And this is the name of the model. I have to give the path urdf slash xrc slash testboard underscore description slash. And now I'm hoping this will give an error. Yes, this is a common error that all people who are new to ROS face. So this is a ROS. This is an Ubuntu terminal. This is not a ROS terminal. This is not a development environment only for ROS. So we have to inform Ubuntu that we want to use ROS commands like ROS launch. So what we do for that is we source the environment. So basically we are overlaying ROS on this terminal.
Yeah, that's very common for the application. It annoys me a lot.
No, you take it easy.
Yeah, this is
Taking a So this is how it's visualized, and in the display.launch file there was also it also opened a joint state controller. This is basically a GUI, and using this you can control the robot, use it for simulations. As in this is using a GUI, but you can through the program also you can control this. So this is basically the as in it's accurate dimensions and the CAD of our robot. So this is one very important thing in a tool that it gives. And one more tool that ROS allows is the use of GUIs. Like this is the GUI for our robot, for our arm. So this is so it's not like ROS is only just coding. There are other visualization tools like GUI, and but one thing about RViz is it's mainly concerned with the kinematics. If you want accurate dynamic calculations, which I'm sure is more important to all of you, you can use Gazebo. Gazebo is a engine simulator which takes into account the physics also. So in the .zacro file, the inertia and masses that we gave, that gazebo can use that to accurately model the dynamics as well. Yeah, so that is basically what I have to present today. I also wanted to show one video. This is something that I was luckily able to do just after dinner. थोड़ा उल्टा है but I think this presentation was basically supposed to show what all work we've done till now, so that's why I wanted to show this video. So yes, thank you, and that is the end of my presentation.